Hello. What are the implications of different logging regimes for the future availability of timber? How sensitive is future timber stock to the damage done during logging operations? These questions are of direct relevance for forest management and conservation. We can answer them using sensitivity and scenario analysis in systems models. And in this knowledge clip, I will introduce you to sensitivity and scenario analysis, show how these tools can be implemented, and discuss how results can be interpreted. We will apply both techniques to a simple model of timber volume, shown over here. The model has one stock of timber volume and three flows: volume growth, volume loss due to mortality, and volume loss due to harvest. The converters in this model are the rate of volume increase, the mortality rate of timber volume, the harvest intensity, and the time between successive harvests. And these are the values. Running the model for 70 years and starting with 1,000 cubic meters of timber, we get this volume development over time. And these are the harvested volumes over 70 years. Now suppose that some converter values are uncertain, then it is important to know the impact of this uncertainty on model output. Or suppose we can modify some of these parameters by forest management, then it is of interest to know the effect of these measures on future harvests. In both cases, we want to know how sensitive timber harvest is to model parameters. And this is called sensitivity analysis. In this example, we apply a 10% increase to each of the 4 model parameters. Then we check the effect on the model output of interest. I've selected timber harvested during the second and third harvest as outputs. I'm leaving out the first harvest as this will not be affected by most converter values. Using the standard parameters, the harvested volume is 730 cubic meters. Now, increasing the mortality rate by 10%, we get a reduction in the harvested volume by 3.5%. This decrease is logical, as the higher mortality causes the stock of timber to be smaller. Adding 10% to the rate of volume increase has a much greater effect. It leads to a 20% increase in harvested volume, and again, this is to be expected, because more timber growth means higher timber stocks, of which 80% is harvested. Increasing the length of the logging cycle also leads to more harvest, in this case because the longer period of recovery after harvest. But the strongest effect was observed when increasing logging intensity. A 10% increase in intensity leads to a reduction of over 1/3 of the logged volume. What happens here is that the more intensive harvest leads to a low recovery of timber volume. So, overall, it is clear that timber yields in the second and the third harvest are most sensitive to logging intensity and least sensitive to death rate. The high sensitivity of logging intensity and the length of logging cycle suggest that changes in forest management are important for timber harvests. In summary, in this sensitivity analysis, we applied equal changes to model parameters. We did so for each parameter separately and for all of the model parameters. Sensitivity analysis may not be the most appropriate tool if we would like to evaluate the impact of management on resources. Then we would like to test larger changes for several parameters at the same time and not for all of the parameters. And this is called scenario analysis. It can be used to evaluate the effects of scenarios that combine various intensities, frequencies, and modes of exploitation. So let's conduct a scenario analysis in our timber model to evaluate the effect of forest management on future timber production. Suppose we're interested in the effects of logging intensity and logging frequency on timber yields, and to evaluate this, we can vary the logging intensity from 50 to 90% and the length of the logging cycle from 20 to 50 years. We also conduct simulations for all possible combinations of these two. Here is part of the results. As we've seen in the sensitivity analysis, timber volume increases with the length of the logging cycle. And, over here, timber volume decreases with the intensity of logging. If we show all 20 simulations in one table, it becomes a little bit hard to interpret, but a 3D graph may help. So here we can see that the effect of the logging cycle length on timber volume depends on the logging intensity. It is much stronger for low logging intensity than for high logging intensity. This graph also shows that there are different combinations of logging cycle length and logging intensity that yield the same amount of timber. So, Let me summarize what you've learned. I've shown how to perform sensitivity and scenario analysis in systems models. I've also discussed the interpretation of results of both types of analysis. Thanks for your attention.